Graad 10, kom ons gaan kyk na die voorstelling van getalle. How to represent numbers. There's 3 ways of representing numbers. You can either draw a picture of it on a number line, getalle lyn, en dan kan ons dit in getalle skryf op 2 maniere. Intervalnotasie of versamelingskeerder notasie. You can write it out as numbers 2 ways. Interval notation and boulder set notation. Now it's very, very important that you must know that you can draw pictures of any numbers. But when you write down numbers, you can write real numbers only as, or when you use interval notation, it can only present real numbers. Intervalnotasie kan net reële getalle voorstel. Nou weet julle al uit graad 9 en uit die vorige lesse wat reële getalle is, dis alle getalle wat bestaan. Goed, versamelingskeerder notasie kan ek alle getalle families voorstel mee. And the way we write this is a bit more complicated than interval notation. There's this little fancy bracket that we use. Then we write down the variable x. We usually use x, a double point, and then we've got our restriction, and that we use inequalities in. So met ander woorde, hier staan van na 2 tot presies op 3. So ek lees hom van die x af. So alle getalle is groter as 2 of kleiner of gelyk aan 3. En dan die laaste deel is 'n kommapunt wat sê in watter familiegroep behoort hierdie getalle. So ons gaan eers 'n bietjie werk met intervalnotasie. Ag nie interval versamelingskeerder notasie, boulder set notation. We're going to work with that first. So let's start with that, and I'm going to show you when we write out integers greater or equals to 3. How will we write it in boulder set notation? That bracket, x, double point, and its integers greater and equal to 3. So we've got all integers greater and equal to 3. I'm talking about the family group integers that we represent with a z. So this, if you read it from left to right, will be the variable x, all the numbers greater or equal to 3 that belongs to the family integers. So if you draw that on a number line, you can put in a 3 on your number line. Because there's an equals to, the dot at the top is going to be colored. And then, remember, it's integers, so it's not the fractions between. So we're going to make little dots on each integer, and we're going to show either by an arrow or dots that this goes on. So if you look at the picture, you can see clearly that it's only the integers 3, 4, 5, etc. up to infinity. Okay, kom ons kyk na die volgende voorbeeld. Heelgetalle kleiner as 5. Heelgetalle kleiner as 5. So ons gaan weer x, dubbelpunt x, kleiner as 5. En van watter getalle praat ek? Weer van die heelgetalstelsel. En dis is kom graad 10, so belangrik is dat ek hierdie simbole nou al reeds moet ken. So as ek dit op 'n prentjie voorstel, dan gaan ek sê kleiner as 5, so ek gaan na die kleiner kant toe op die is gelyk aan. So ek gaan 4, 3, 2 en 5 is nie ingesluit nie, want daar's nie 'n is gelyk aan nie. Dis heelgetalle kleiner as 5. En dan wys ek ook dat dit aangaan. Onthou, as dit heelgetalle is, beteken dit die breuke tussenin is nie deel daarvan nie. en daarom maak ek kolletjies to show that there's no fractions involved. Kom ons kyk, natural numbers smaller than 4. Natural numbers smaller than 4. Natural numbers smaller than 4. Easy. Now, for us to be able to draw the picture, we must know what is natural numbers. Remember, whole numbers, there's a difference between whole numbers and natural numbers. Telgetalle en natuurlike getalle. Telgetalle begin vanaf 0 af en natuurlike getalle begin vanaf 1 af. So as ek kleiner as 4 natuurlike getalle, dan gaan ek sê hier is 4, kom ons begin daar, 4, 3, 2, 1, kleiner kantjie toe. As ek kleiner as 4 natuurlike getalle, ons kan 0 op insit, natuurlike getalle begin by 1, en as ons kleiner as 4 gaan, dan sal 4 nie ingesluit wees nie. So the picture is only going to be 1, 2, and 3. But to be able to draw these pictures, guys, we've got to know our definitions of whole numbers, integers, natural numbers, real numbers, etc. Baie belangrik. Kom ons kyk na die laaste enetjie. Nee, ons gaan nog na 'n paar kyk. Heelgetalle tussen -2 en 3. Heelgetalle tussen -2 en 3 en dan sê hulle -2 is uitgesluit en 3 is ingesluit. Heelgetalle tussen -2 en 3. Tussen -2 en 3. Kyk, ons skryf juffrou nou die -2 eerste en die x in die middel en 3 laaste. Jy kan duidelik sien. Ons gebruik kleiner as dit tussenin is, gebruik ons altyd kleiner as tekens met die x in die middel. En hulle sê, -2 is uitgesluit, so there's no equals to, but 3 is included, so there's equals to, and this is going to be real numbers. Real numbers, all the numbers that exist. Dis hele getalle. So ek moet mooi lees. Nee, hulle sê dit gesê heel getalle. Sorry, not real numbers, integers. Integers. So let's draw the picture of this. So on our number line, we've got a -2, -1, 0, 1, 2, and a 3. 3 is included. So we're going to color that dot. 2, 1, 0, -1, and no arrows, because -2 is not included. So daarso het ek dan die prentjie van heelgetalle van na -2 tot presies op 3. Let's look at another example. Okay, real numbers greater or equals to 3. Real numbers greater or equals to 3. Greater or equals to 3. And that's real numbers. If you read it from the left to right, it exactly says that. You study this, the funny bracket, x, double point, x greater or equals to 3. X is not between two numbers, so it's not written that way, it's written that way, and now I can draw the picture. Real numbers, I cannot present by dots because real numbers is all the fractions included. So now look at this. I've got a 3, and the dot is colored because there's an equals to, but now I want to include all the fractions, everything between these integers. So now I'm going to draw a line with an arrow showing it's all the numbers that exist greater or equals to 3. So can you see the difference between these pictures and that one? The difference is in these pictures there's colored dots. So this is all integers. Dot, dot, dot. The fractions in between is not included. Maar by hierdie ouetjie trek juffrou 'n streep. Hoekom trek ek 'n streep? Want die miljoene breuke tussenin is nou ook ingesluit. En waar kom die verskil in? Tussen wat hier staan. En dit moet ons ken. Dis 'n heelgetal polletjie, natuurlike getal polletjie, heelgetal polletjie, real number, line. Okay. Reële getalle kleiner as 7. Reële getalle kleiner as 7. Dis funny bracket. Kleiner as 7, that's greater than. You need a smaller than 7. And that's all the real numbers. Again, all the numbers that exist. So as ek getallelyn teken, daarso 7, there's now equals to open dot. Now equals to, the dot is not colored, and now it's smaller than, and it's real numbers, so I'm going to draw a line to the smaller side, want ek het my klein kantjie, minus oneindig, en my groot kant, plus oneindig. Okay, en dan het ons real numbers between -5 and 4. Real numbers between -5 and 4. Again, the same thing. Now it's between. -5 is the smaller one, so I write it first. X in the middle, and 4 is the bigger number, so I write it last. And they say that -5 is not included, but 4 is included. 4 is part of it, but -5 not. And this is all real numbers. So let's draw the picture. Okay, we've got our number line. We've got a -5, -4, -3, -2, -1, 0, 1, 2, 3 en 4. En ons sien, -5 is uitgesluit, ook polletjie. 4 is ingesluit, ingekleurde polletjie. En dan het ons al die getalle tussenin, so I'm drawing a line because it's all the real numbers that exist, all the thousands, millions of numbers that exist, from after -5 up to exactly on 4. And this is now our builder set notation, the way we write it, and now again drawing pictures on number line.